Hi and welcome back. In this video we're talking about dictionaries and objects, and we're going to introduce this concept of object-oriented programming. Now, the way I've got planned to introduce this to you, I'm pretty chuffed with. I think it's going to be quite understandable. So let's get on it and see how it turns out. We've looked at dictionaries as things that we can use to represent things in our program. For example, we can have a dictionary that represents a student. And we can say, my student is equal to this new dictionary that has a name and potentially has some grades. Something like that. Now, in our program, this dictionary represents what we think of a student. And in other parts of our program, we may do things like print out the student's name or calculate the average grade of the student and use this dictionary as though it was a student. Even though, of course, we know that real students in the real world have a lot more properties like an address and, family and things like that. In our program, we don't care about those other properties. We only care about the properties that we're going to use. So in our program, this dictionary can represent a student. And if we expand our program and we need more properties, we can always modify the structure of this dictionary and add them in. And this concept of having something that represents a real-world entity is pretty powerful in programming, and it allows us to start thinking of our programs in terms of what they do as opposed to how they do it. Let's move on and assume we want to calculate the average grade of this student so that we can, for example, put it in some sort of report somewhere. I think you can already calculate the average grade of this student quite easily, so I'm going to ask you to pause the video and give this a go. Try to implement a function that will return the average grade of this student. I hope you got that. What we're going to do is we're going to define an average grade function. It's going to take one parameter that is going to be the student, then a colon at the end, of course, and all it's going to do is it's going to add up the grades that we're going to do with the sum of the student grades, and it's going to divide that sum by the length of the student grades. The length, again, is the count of how many there are, and there are 4 in this case. And naturally, it's going to return that calculation. So now if we wanted to print out the average of my student, we can do that. Again, all we're doing here is we are evaluating my student. It's just a dictionary. We're calling the average grade function with that as an argument. So the value of my student, this dictionary, will then go into the student parameter. And that's going to return these calculations here. And then we're going to print that out. So let's run it. And as you can see, we get 86.75, which sounds about right. However, and here comes the interesting bit, there is a flaw with this entire program. I'm going to just delete that. The flaw is not in the code. The code's totally fine. It does what it's meant to do. It calculates the average grade. The student is a dictionary that's defined up there. All the code works, and it prints out, or it gives us the value that we want. But the flaw is in its design. Not user interface design, but in software design. And this is a concept and a whole topic that the majority of coding tutorials out there just completely skip over. But I think it's pretty important, and I think it's a good way to explain object-oriented programming. The flaw in the software design is that these two functions are essentially unrelated, even though they are very closely or seemingly close related. They are essentially disjoined. And what I mean to say by that is you've got this function, and in a large program, potentially you could have a function somewhere in an entirely different file altogether that gives you the average grade. And in a different file altogether, you could have this student. So these could be in completely different places physically in a large project. However, what we say that these two things are tightly coupled in that the average grade function requires that the parameter be a dictionary, and it requires that the parameter have a key grades in it in order to be able to fulfill its purpose. It's totally fine for a function to have those requirements, but not when it's also possible for the function to be in a completely different place. Because then let's say you wanted to change grades for resource or for results, for example, you'd have a mayhem if you've got functions all over the place that rely on the student to have a grades key, but now you change it. So this is the flaw in the design of this program. We've got a function that is not living with this student, but is tightly coupled to that student, or to this dictionary structure. So it would be great if we could have our function living inside the dictionary, so that it lives in the same place as the data that it acts on. Something like this. Let's say we